2.6 combinations of functions and composite functions. All right, let's start off with finding the domain of a function. You want to ask yourself, what can x not be? The domain of a function is all x values that result in a real f of x. In other words, when you're plugging, let's say, a value into the equation, do you get an error on your calculator, or do you get some number? Is it some real number? If you get an error, then that number doesn't exist. All right, now if the function is a line, then there's no restrictions on x. Unless it's a vertical line, then it's not a function. If the function is a rational expression, you look at then the denominator. What x values make the denominator 0? If it's under a radical, you have a radical, then you look at what x values make the radicand less than 0. We really look at that doesn't work, right? Less than 0. So we want to find what makes the radicand positive. Let's look at a couple examples of find the domain of the given function. All right, looking at number 1 right here, we have f of x is equal to 3 times x minus 7. So remember, we're looking at what can x not be. So do I have a fraction here? No. Do I have a radical here? No. So are there any restrictions on my domain? Can I plug in negative 100? Yeah, and get some real number? Yeah. Can I plug in 0 and get some real number? Yeah. Can I also plug in positive 256 and get some real number? Yes. Plugging those into my calculator, I get some value. So therefore, there are no restrictions on my domain. So for number 1, my domain is from negative infinity to positive infinity. All right, now let's look at number 2. Looking at number 2, do I have a fraction? Yes, I have a fraction. So because I have a fraction, is there something that's going to make my denominator 0? Yes. So a lot of times we can tell by looking at it what makes the denominator 0, but remember that all you have to do is set the denominator equal to 0 and solve it. So if I had 3 times x minus 7 equals 0, I set both of my factors equal to 0. So I have 3 equals 0, x minus 7 equals 0. So this 3 equals 0, that just divides out. There's no x that's there to solve for. So I'm going to add 7 to both. So I get x equals 7. But remember, we just found out what is not in the domain. So since we found out what's not in the domain, remember every other number works. Negative 1 works, negative 2.85 works, positive 1,382 works. All of those numbers work. The only number that doesn't work is that 7, because it's going to give us 0 in the denominator. So looking at, before I do my interval notation, kind of just doing a quick graph, right? I have 7, 6, 8. 7 is not included because it doesn't work, but everything to the left is and everything to the right is. So therefore, my domain for number 2, my domain is from negative infinity to 7. Then I have my u, then 7 to infinity. All right, let's look at number 3. Number 3, I'm going to do the same thing. I'm going to look at number 3 and I'm going to say, all right, what can x not be? Well, do I have a fraction? No, I don't have a fraction, so I don't have to worry about that. Do I have a square root? Yes, I have a square root. Well, because I have a square root, I know that when I take the square root of the number that's underneath there has to be positive. If it's a negative, then it's not a real number. So it has to be positive. What about 0? The square root of 0 is 0. So 0 works. The square root of 1 works. The square root of 4 works, and so on. Even the square root of 2.852. That gives you some number. What's not going to work? Anything that's negative underneath here. So that's what we then do. We take whatever is underneath here and we set it greater than or equal to 0. So I have x minus 7 is greater than or equal to 0. Add 7 to both sides. So I have x is greater than or equal to 7. So now I just do a quick little graph here, right? I have 7 again, 6, 8. This time my 7 is included. So if I plug in 8, I get the square root of 8 minus 7, which is the square root of 1, which gives me some real number. But if I were to plug in 6, 6 doesn't work. So therefore my domain, my lowest possible value is 7, which is included to infinity. Let's look at number 4. So now we have a square root in the denominator. Much like the previous one, right, it even has the same square root. The only difference is now we have something in the denominator. So can the denominator be 0? No. But now remember, it's not just about the denominator being 0, it's that underneath the radical has to be positive values. So really the only difference between number 3 and number 4, now we say x minus 7 is greater than 0, not greater than or equal to, because it's in the denominator, so it can't be 7. So add 7 to both sides. So x is greater than 7. So my domain here is from 7 to infinity. Another type of example. Once again, we look at, do we have a fraction? So since we have a fraction, we know that 0 cannot be in the denominator. So this right here, we look at what makes that 0. Well, what makes that 0? X minus 7 equals 0. So x equals 7. But remember, this is not in the domain. But if we look at the numerator has a radical, square root. So we know that whatever's underneath the square root has to be positive. Can I have a 0 in the numerator? Yes. So whatever is underneath there, right, we set x minus 2 greater than or equal to 0. Solve it. Plus 2 plus 2. So x is greater than or equal to 2. All right, now let's put these on a number line. We have to put this in interval notation. So putting this on a number line, right, our smaller value is 2. So I'm going to start with 2 here, and then I'm going to start with 7 here. Is 2 included? Yes, 2 is included, and then it says that we're going to the right. Up, but we come across 7. And is 7 included? Nope, 7 is not included. So it's greater than 2, but not including 7. And then in this direction also, all the way there. My domain, my lowest possible value is 2, which is included, to 7, which is not included, to then 7 on the other side, to infinity. All right, let's look at this complex fraction. We have a fraction inside a fraction. Ultimately have two fractions here. What can you not have in the denominator? 0. So we look at this first fraction that's here in that denominator. What's going to make that denominator 0? X equals 0. So we just found out what's not in domain. Now we look at the larger fraction. This right here in my larger fraction is the denominator. So this part right here cannot equal 0 also. So we set 2 divided by x minus 3 equal to 0. And now we're going to solve this. So I'm going to add 3 to both sides. So then I have 2x is equal to 3. Multiply, you can go ahead and multiply both sides by the least common denominator. So here my x divides out and I'm left with 2 equals 3x. Divide both sides by 3. What else do I have? X equals 2/3, which is, again, not in domain. Everything else is in the domain. Every other possible number is in the domain. So what value is smaller? 0. And then 2/3, not included, not included. Everything between, everything to the left, everything to the right. So the only thing that's not included is 0 and 2/3. So my domain, let me make enough room to make this domain. So my domain is from negative infinity to 0, 0 to 2/3, and then 2/3 to infinity. The sum and difference of functions. So this is when you're just adding functions together. You plug in the given functions and you combine your like terms. When you're subtracting, right, you plug in the given functions, you distribute the negative through the second function, distribute that negative through the second function, and then you combine like terms. Other operations of functions, you find the product and you multiply, which just means that you basically distribute. And then you combine your like terms where you have like terms. The quotient, when you're finding the quotient, f of x divided by g of x, do they have any common factors? Then you can reduce. If they don't have any common factors, then you can't reduce. Let's look at an example here. Find f plus g, f minus g, f times g, and f divided by g. All right, here's our given functions. So the first thing I'm now going to find is f plus g. Well, that's the same thing as f of x plus g of x. So I have x squared minus 3x plus 5 plus x plus 4. Now I put these in parentheses because I'm just showing that here's my f of x and here's my g of x. But what operation is happening between them? Addition. What happens to parentheses with addition? Well, you don't need them. Okay, so your parentheses go away and you combine your like terms. So I have x squared, then I have minus 3x plus x, so I have minus 2x plus 5 plus 4, so I get plus 9. So this is my f plus g. Now, as you're doing the homework, it will ask you about the domain. I'll go ahead and say here, what is my domain here? Do I have a fraction? No. Do I have a radical? No. So therefore, my domain is negative infinity to infinity. All right, now let's look at f minus g. So my next operation was f minus g. So that's f of x minus g of x. So my f of x, x squared minus 3x plus 5 minus my g of x, x plus 4. So now when I have subtraction, do my parentheses matter? Yes, my parentheses matter, so I know I have to change my operations. Minus x, minus 4. My first parentheses stays the same. Combine my like terms, x squared minus 4x plus 1. So this is my f minus g. Again, do I have a fraction? No. Do I have a radical? No. So therefore my domain is from negative infinity to infinity. My next operation is multiplication, so f times g. So I have x squared minus 3x plus 5 times x plus 4. So what do I need to do here? Distribute. So my parentheses do matter. So I'm going to go ahead and say x to the third plus 4x squared minus 3x squared minus 12x, distributing now my 5, plus 5x plus 20. Combine my like terms, so I have x cubed plus x squared minus 7x plus 20. So this is my f times g. For the domain, do I have a fraction? No. Do I have a radical? No. So therefore my domain is negative infinity to infinity. My last operation is division. So I have f divided by g. So that's the same thing as f of x divided by g of x. So let's go back up and look at what our f of x function is. So I have x squared minus 3x plus 5 divided by x plus 4. Can I factor the numerator? No, there's no factors of 5 when they're both the same sign that are going to add up to a negative 3. And the only factors of x plus 4 are x plus 4 in itself. So therefore this is in reduced form. There's nothing else I can do with it. For my domain here, I do have a fraction this time, so I know that x cannot be negative 4. So for my domain, I have from negative infinity to negative 4, and then from negative 4 to infinity. Composition of functions. F of g of x is when you take g of x and you plug it into f of x. This symbol that's right here means composite function. Let's look at some examples for finding the composite function. These are not operations. It's taking one function and plugging it into the other function. So find the composite of f of g of x. So we'll start with that one. So f of g of x is when we're going to start to write our f function and then plug in our g of x function. So f, I see I have 2, then I have my x squared. So I'm going to go ahead and say x plus 5 squared and then minus 3. So now simplify. X squared plus 10x plus 25, then minus 3. 2x squared plus 20x plus 50 minus 3. So f of g of x is equal to 2x squared plus 20x plus 47. B says find the composite of g of f of x. So b g of f of x. You're plugging in your f of x wherever you see x. So now I'm going to go back up and look at my g function. So I have x plus 5. So the first thing I have is x. So I'm going to go ahead and plug in my f of x. So I have 2x squared 3. And then plus 5. So here there's nothing to do outside of my parentheses, so therefore I have 2x squared plus 2. Don't try to get all fancy and, go through factoring. You don't need to. Don't factor if you don't have to. I'm going to do f of g of 2 a little differently. We have this function here, so we can plug it in and check our answer if we wanted to. But I'm going to go ahead and do this a little bit differently because it's find, it says find f of g of 2. So instead of then plugging in an x like we did up here, f of x, or up here where we plugged in g of x, we're actually plugging in g of 2. So it's f of g of 2. So what function are you really plugging that 2 into? You're really plugging that 2 into my g function. So the first thing I'm going to do is then find g of 2. So g of 2 is equal to 2 plus 5. So g of 2 is equal to 7. Plugged in 2 right here. So I got g of 2 equals 7. So since now I have g of 2 equals 7, then I'm going to replace g of 2 with 7. And now I'm going to find f of 7. So I have 2 times 7 squared, right? And then minus 3. 7 squared, 49 times 2. So I get 98 minus 3. So I get 95. Now I can also check my calculator plugging it in here. I can plug in 2 into my composite function and get the same thing. Okay, now we're going to check this. So here I have a graphing calculator. I have a graphing calculator because that's what I have on my computer. But I have 2, open my parentheses. We have 2 squared plus 20 times 2 plus 47. Press enter and I get 95. So remember, we got 95 by plugging 2 into g, simplifying that, then plugging 7 into my f function. That's what it means to be the composite function. You're taking one function and plugging it into the other function. The domain of a composite function is the set of all x such that x is in the domain of g and g of x is in the domain of f. If x is not in the domain of g, then it must not be in the domain of the composite of f of g.